Good morning. Today we're going over methods of solving math problems, and that includes a formulaic method, which you're probably already familiar with, and dimensional analysis, which might be a little bit new and uncomfortable at first, but we're going to use it a lot. So we're going to have to understand how to do that in this class. So just to compare here, we've got the formulaic method that says we want to convert from one thing to another thing, and I have a formula to do that, and I just use algebra to solve the equation. So like as, for instance, we solve temperature conversions using a formulaic method, and that is, for instance, that the degrees in Fahrenheit are going to be equal to 9/5 times the degrees in Celsius plus 32. And there are some things that we have to use the formulaic method for, but not all of them, in fact, not most of them. And the challenge is that if we use the formulaic method for everything, then we have to memorize a new formula for every single potential conversion. And there's a lot of potential conversions, and it's just not practical. So instead, sometimes where possible, and that's in this class going to be much of the time, we're going to use something called dimensional analysis. And that's just a really big fancy name for saying that I am analyzing, or I am looking at the dimensions, or that is the units. Now remember, we talked about in our last lecture on numbers that units are an essential part of the measurement. They are just as important as the number. In fact, when it comes to dimensional analysis, they are more important than the number value, because that's what we're going to be using to help solve the problem is the units. So dimensional analysis, that's just fancy for we're looking at the units to help us solve the problem. And the way that we solve a dimensional analysis problem is we recognize things that are equal. We call these equivalencies. So for example, we know that 1 inch is equal to 2.54 centimeters. That is an equivalency because this is equal to that. And that'll help us convert between inches and centimeters. And I could memorize a formula for that. I could say my number of inches will equal the number of centimeters divided by 2.54, and I can memorize that, but nobody wants to memorize formulas for everything. Instead, we just say, okay, I've got an equivalency. I'm going to use that using my dimensional analysis. Here's a couple other examples of equivalency. We know that 1 pound is equal to 454 grams, approximately, and that 1 liter is equal to 1.06 quarts, approximately. So this is equal to that. These are all equivalencies. So now we're going to take ourselves back to algebra and remember that whatever I do to one side of my equation, if I do it to the other side of the equation, that it still is equal. So we're going to take this equivalency and say, what would happen if I divided both sides by 1 inch? And hopefully you understand that anything divided by itself is just equal to 1. And so what we get is that 1 is equal to 2.54 centimeters divided by 1 inch. And it looks weird at first. It looks like I'm saying that 2.54 is equal to 1, but I'm not. This does not work unless I include those units, the centimeters and the inches, right? Otherwise, it's nonsense. But if I include those, then 2.54 centimeters divided by 1 inch is equal to 1. And I could do it the other direction too, right? I could take 1 inch is equal to 2.54 centimeters, and I could choose to divide both sides by 2.54 centimeters instead. And again, because anything divided by itself is equal to 1, those cancel out. And I get that 1 inch divided by 2.54 centimeters is equal to 1. So this one equivalency right here, that 1 inch is equal to 2.54 centimeters, that gives us 2 conversion factors. The first conversion factor is 2.54 centimeters divided by 1 inch. And the other conversion factor is 1 inch divided by 2.54 centimeters. And since these two things are equal to one another, when I divide one by the other, or the other by the 1, then each of these is equal to 1. So these become conversion factors because I can multiply anything by one of these conversion factors, and I don't change the value of that thing. I only end up converting it into a new set of units. And every equivalency has two conversion factors, one where the thing on the left is on the top, one where the thing on the right is on the top, and so on and so forth. And you get to choose which one of those conversion factors you use depending on the problem that you are trying to solve. So let's give an example here. For instance, let's say that I want to know how many inches are in 30 centimeters. Now, you guys know how to do this using a formula. You might even be able to do this in your head without setting it up, but we're going to use dimensional analysis just so that we can practice using the method. So we can start with what we're given, 30 centimeters, and then we're looking for an equivalency that contains centimeters so that I can cancel them out. And it'll help if I have some sort of equivalency that contains inches, because that's the unit that I want. So I'm going to use this one right here, this equivalency, and one of those conversion factors that comes from that equivalency to solve the problem. So I'm going to take 30 centimeters and I'm going to multiply it by one of these conversion factors. And I hope you see that the conversion factor on the right is going to get me the right answer. Because when I put 1 inch divided by 2.54 centimeters, then the centimeters cancel, those units cancel. It's just x divided by x. The units cancel, and now I'm only left with units of inches, which is what they wanted. So now I'm sure that when I plug this in, that I'm going to get the answer in inches. So I bring out my handy dandy calculator and I say I've got 30 times 1. I don't have to do that part, but it's up here, so I'll do that. Divided by 2.54. And that gives me a value of 11.8 inches. That solves the problem. So we use dimensional analysis. We take our initial value, we multiply it by some conversion factor that helps us get rid of one set of units and convert to a different set of units to solve the problem. Sometimes I'll write it like that. Sometimes I might write it like this. I'll use this like continuous line. This method is also called the factor label method. If you've heard factor label, where each one of these vertical lines indicates a multiplication. Everything on top gets multiplied, everything on the bottom gets divided through, and so on and so forth. So that was a very simple one. Let's do one that's a little bit more complicated. We can do multiple steps here. So for instance, what would happen if I asked how many centimeters are in 1 foot? So we're given 1 foot. I want units of centimeters. I have this conversion factor up here where I know that 1 inch is 2.54 centimeters. And we're given feet though. So I need to be able to convert between inches and feet. And again, if this was a test, I would give it to you because it's an English conversion factor, so you don't need to know this. But 1 foot is equal to 12 inches. So now I have two equivalencies that will help. And we're going to start with 1 foot, the thing that we're given. 1 foot. And we want to get rid of units of feet, so I'm going to use this equivalency and put the feet on the bottom. 1 foot, 12 inches. Feet cancel. Woohoo! Now I want to get rid of inches, so I'm going to use this equivalency that uses inches, and I'm going to put inches on the bottom so that they cancel. 1 inch, 2.54 centimeters. Inches cancel, and I'm left with units of centimeters, so I know that I did it right. And now I just plug this into my handy dandy calculator. And I'm going to ignore the ones. I don't need the ones. But what I get then is 12 times 2.54. And that gives me 30.48 centimeters. Okay, so next, let's do just a few more extra examples. Let's try this. Let's convert 145 pounds to kilograms. And in this case, I'm going to give you, given that 1 pound is equal to 453.6 grams. Now again, because this is an English unit, I have to give you something to get you into metric units. But from there, you might have to come up with the metric prefixes to go from grams to kilograms, because you do have to memorize those. But let's try this. 145 pounds. That's where we're going to start. And we're given that 1 pound is equal to 453.6 grams. So this is an equivalency. And I'm going to use that to make a conversion factor that puts 1 pound on the bottom and my 453.6 grams on the top. I'm going to do that because that way my pounds cancel. I get rid of those units that I didn't want. Now I'm at grams, which is great, but they want kilograms. So this is the tricky part. Here's where you have to remember your metric prefixes. And the way that I remember them is to say that 1 gram is equal to 1 gram. That makes sense. And kilo, I memorize, is equal to 10 to the third. So 1 kilogram is equal to 1 times 10 to the third grams. I have created my equivalency, and I can use that as a conversion factor. And my grams are going to go on the bottom. 1 times 10 to the third, that's basically 1,000. Grams goes on the bottom, and 1 kilogram goes on the top. And my grams cancel, and I'll be left with units of kilograms, which is what they asked for, so I know that I'm done. Let's plug this in. We'll see 145 multiplied by 453.6 divided by 1 times 10 to the third. Now this is tricky, guys, because if I say 1 times 10 raised to the, let's see, where's my little caret? I don't have a caret. Raised to the third. Oh, perfect. I'm just going to cube that right there. I get the wrong answer. Do you guys know what I did? Let me show you what I did again. 145 multiplied by 453.6 divided by 1 times 10 to the third. Here's what happens when you just plug it in exactly that way. It divides by 1, and then it takes everything you just did and multiplies it by 10 to the third. So it brings the 10 to the third up to the numerator, and you're getting an answer that's off by a factor of 1,000,000. That patient died. So I did this on purpose because I want you guys to know how to use your calculators, and you've probably, I'd say at least 20 to 30% of you have encountered this error. So let me show you how to prevent this issue. We're going to clear that out, and we have a couple options. I could do 145 times 453.6, and then I can divide by, if I put this in parentheses, it should solve my problem. Close the parentheses. That keeps everything together on the bottom, being divided by that thing. And that gives you the right answer of 65.8 kilograms. So when in doubt, use parentheses. That is a super helpful thing to do. But there's another little trick that can also be extremely helpful, and I want to show it to you just because some of you might appreciate this. You can also do 145, multiply that by 453.6, and divide that by 1 EXP, that's times 10 raised to the third. And I don't need to use parentheses when I use the EXP button, or on your calculator it might be a capital E, capital E. That really should be a capital E. It's very confusing that it's a lowercase e. Should be a small capital E. But 1 times 10 to the third, that keeps it all together. It says that it's part of that 1 and that you shouldn't put it up on top. So if you use the EE or EXP button, then you don't need to use parentheses. That's a little trick that might be helpful. But you, either way, get the answer of 65.8 kilograms. Okay, let's do another one with metric conversions because they can be a little bit tricky and it's good practice. So next we're going to convert 2.89 gallons to milliliters. And I'm going to give you, given that 1 liter equals 1.06 quarts and that 1 gallon is equal to 4 quarts. All right, so I gave you 2 conversion factors, one that contained English to English, one that was metric to English, just to get you out of the English factors. So starting with 2.89 gallons, I'm going to need to use the equivalency that contains the units of gallons. So I'm going to use this one right here, that 1 gallon is equal to 4 quarts. 1 gallon is 4 quarts, and I put the 1 gallon on the bottom so that they could cancel. Then I'm in quarts. I'm going to use the conversion factor that has quarts. And I'm going to put quarts on the bottom here so that they'll cancel. And if I do that, that gets me all the way from gallons to, now I'm in the units of liters. Great. But they asked for milliliters. So I'm going to need one more factor that I have to have memorized because it's a metric factor. And again, I memorized, if 1 liter is 1 liter, I memorized that milli means times 10 to the negative third. So then 1 milliliter is equal to 1 times 10 to the negative third liters. And I put liters on the bottom so that they'll cancel. And that's 1 milliliter. So liters cancel. And now I've got my units in milliliters. Now there's more than one way to put this together. I know a lot of students that like to put parentheses around this, multiply everything through, put parentheses around this, divide everything through. I personally like to say this times this divided by this times this divided by this times this divided by that. That is, everything in the numerator gets independently multiplied and everything in the denominator gets independently divided. So here's the way I do it. I say 2.89 times 4, because that's on the top. I'm going to ignore that 1 because it's just a 1. And I'm going to ignore this because it's just a 1. But now I need to divide by that because it's on the bottom. So I'm going to divide by 1.06 times by 1. Don't have to do that part. And now I need to divide by 1 times 10 raised to the negative 3. And I'm going to need to use the 3 and the negative sign, not the minus sign. Your calculators can be finicky on that. So divide by 1 times 10 to the negative third. And I should get the answer of 109,000 milliliters. Sorry, that's not 109,000. That's 10,900 milliliters. Okay, that's the right answer. Now again, you'll get the same thing if you do 2.89 times 4 times 1 times 1 equals, and then divide that by parentheses 1.06 times 1 times 10 to the negative third. Okay, that's everything on top got multiplied, everything on the bottom got multiplied, and then you divide what was on the top by what was on the bottom. You'll get the same answer. Whichever way is the most comfortable for you is the way that I would recommend doing it, okay? Because if you're more comfortable with it, then you're going to be better at it, regardless of whether it's the way that I do it. So long as it's correct, then it's not a problem. Okay. Next, we're going to convert a distance of 150 kilometers into feet. So 150 kilometers to feet. And given that 1 inch is equal to 2.54 centimeters. And I will also have to give you that 1 foot is 12 inches. I already did that previously, but just as a good reminder, it's helpful. All right, so now just looking at this, I see I have feet, but I don't have kilometers over here. So, ooh, that's tricky. I'm gonna need a conversion factor to go from kilometers to something else. Well, I've got centimeters. Those are both metric units of length, but I don't know how to go from kilometers to centimeters. But I do know how to go from kilometers to meters. So I'm going to say 1 meter is 1 meter. And kilo means times 10 to the third. Therefore, 1 kilometer is 1 times 10 to the third meters. And if I can get to meters, then I know how to get to centimeters because I memorized that centi means 10 to the negative 2. So if 1 meter is equal to 1 meter, then 1 centimeter is equal to 1 times 10 to the negative 2 meters. That's an M. All right, so now I have the conversion factors I need to get me from kilometers to meters, and I can get from meters to centimeters. I'm going to need centimeters because I'm going to inches. So it can be helpful to, at the very beginning, identify what you're given and what you're looking for, then collect all of the factors that you might need to do it, and only then do we start to set up the problem. Well, let's start here. 150 kilometers. And here's my kilometers. 1 kilometer is 1 times 10 to the third meters. Use that. It can be helpful to check that off. Now I'm at meters. Here's my other meter. So I'm going to use this guy. That 1 times 10 to the negative 2 meters is equal to 1 centimeter. Check, used him. Now I'm at centimeters because I've canceled out my kilometers and I've canceled out my meters. And so I'm going to use this guy right here that says 2.54 centimeters is equal to 1 inch. Centimeters cancel, centimeters. Use that guy, and now 12 inches in a foot. 12 inches in 1 foot. Inches cancel. And I have feet, which is what they wanted, so I'm done. Oh, that was tricky. That was a lot of conversion factors in a row. But a couple of them were metric, so you need to be really good at going back and forth between those. We can do that. All right, so we start with 150 kilometers. We multiply that by 1 times 10 to the third meters in a kilometer. We divide that by 1 times 10 to the negative 2 meters in a centimeter. Then we divide that again by 2.54 centimeters in an inch. And I'm going to divide that by 12 inches in every foot. You see, these two are multiplied because they were both on top, and all of these are being divided because they're all on the bottom. And I get something like 492,000 feet. Does that make sense? Can always help to stop and do a gut check and say, well, 150 kilometers, that's actually a pretty long distance. So it makes sense that it would be a lot of feet. That makes sense. All right. So I hope this was helpful. I'm going to do a separate dimensional analysis lecture on some more complicated conversion problems, but this should be a good start for you guys. I hope it was helpful. Have a great day.